Friends, in this video, we will build a similar image search engine. Let's imagine we have millions or even billions of images here. Okay. Now these images could be anything. And then we have a query image. Now we would like to find out top n images which are very similar to our query image among these millions of images. Okay, so that's the application we are going to build. It's a search engine to search for similar images. Okay, so for this we are going to use AI embeddings as well as a vector database. Okay, so the high level architecture looks like this. So we start with these millions of images. Okay, and then we use an embeddings model, image embeddings model, which basically converts each image into a vector of a fixed dimension. Okay, irrespective of the image width and height, each image gets converted into a vector of fixed dimension, and the dimension is determined by which embeddings model we use. Okay, so basically we are going to represent each image as a vector. Now, similar images will have the distance between the vectors belonging to similar images will be small compared to the other ones. Okay, so once we compute all these vectors, we can find out how similar they are using different measures. For example, cosine similarity, dot product, maybe Euclidean distance, etc., etc. Right? In most cases, we use cosine similarity. So let's say the cosine similarity between vector 1 and vector 3 is smaller compared to vector 1 and vector 4, let's say. That means image 1 and image 3 looks similar to each other compared to image 1 and image 4. Okay, so that's the idea. And once we build these vectors, we store them in a vector database. It's a purpose-built database. The data in this vector database are the vectors stored in a structured manner, so that it's easy to find out the vectors which are similar to each other. Okay. All right. Once we build this architecture, and then we have our query image, right? So we would like to find out, let's say, top 5 images which look similar to our query image. What we do is we run the query image also through this embedding model. So we get another vector back. Okay. And using this vector, we query this vector database to find out all the similar top n similar vectors. Now, each vector has a vector ID which is related to the image, so that the vectors we can map them back to the images using those IDs. Okay, so by using a query image, we will get top n images which are very similar to the query image among this collection of images we have. Okay, now this works very fast because of the vector database. So even if we have millions or even billion images, we can very quickly find out the similar images. Okay. All right. First, let's see how the output looks like. So let me go to the bottom. So here we have some satellite images. So the images look like these, the canopy images. And then we have the flyovers or the infrastructure images. Okay, the roads images. And then we have the stadium images. Okay, so these are all satellite images. Okay, these are taken in rural areas as well as urban areas. So we have the stadium images. Okay, and then we have this airport runway images. Okay, so we have the airport images, and we also have the shipyard images with these ships and the sea, etc. Okay, we have these shipyard images. Okay, so these are satellite images, and there are different types and different kinds of images. And then we will use query images to find out the images which are similar to our query image. That's the application we are going to build. Okay. Now, as I mentioned, we are going to use Pinecone for vector database. There are many good vector databases, but I find Pinecone to be very user friendly and easy, and they also offer a free account. So head to Pinecone and you can register using your email ID, and then go to this API key section and create your own API key. Okay, then you can create a project, and then the database which is called index in vector database, we can create as many indexes as we would like for different applications. But because this is a free account, we can only create one free index. Okay, you can upgrade, and which will give unlimited instances as well as the databases. Okay, all right, so let's head to the code. All right, so we need to install a couple of libraries. Pinecone, that's to interact with the Pinecone vector database, and then transformers. We are going to use the transformer library to convert the images into embeddings. Okay, and then we also need a dataset. You can install another library called datasets. It's from Hugging Face. They have good collection of the datasets. Now the dataset we are going to use, it's called this Lauda dataset. It has these close to 6,000 high resolution spatial images. Okay. All right. And then we'll use another library called gdown. Again, you can just pip install, and these are the IDs. So different datasets have IDs, and we can download this dataset as well. Okay, right? So these datasets are created for creating machine learning models. So we have test dataset, train dataset, and validation dataset. So we can download these three zip files, and then we'll unzip these files. Okay, unzip these files. So this is how they look like. For example, within this test, we'll have rural, and then there are these images. Okay, and similarly within the test we have urban as well, and the images. Similarly, we have in train as well as validation. So we have total about 5,000 images. Okay, total about 6,000 images. All right. So when you download the data, this is how the folder structure looks like. So we have the test folder, and within it we have the rural, and then there is the images folder. Here we have all the images, and similarly we have the urban, and images folder, we have all the images, and exactly the same thing is repeated within the train folder as well as the validation folder. All right, so because we have the images organized in these multiple folders slash subfolders, we'll just find out the relative path of all these images, right? So that we can use those paths when creating the embeddings. Okay, so here all we are doing is just creating those paths. Okay, now in this case we are using only the test data, because inserting all these 6,000 images will take quite some time, because we have this free account which is not as fast as the paid account. So we are using only the test images. Okay, so which are about 1,800 images, right? So here we get the paths, and then the path will look like this, right? So these are all the paths of these 1,800 images. So the first image, it looks like this, for example, right? This is the last image, -1 means. So it's a test rural images, and then this is the image name or the file name. Okay, so in this image paths, we simply gather the file location of all the test images. Okay, and then here we are simply going to read those three images in this PIL format. Okay, so all we are doing is, so we have created this function called load images, and in this case we are loading the first three images. So it simply takes the paths, and from the path it simply read those three images, and then the metadata is simply the paths. Okay, so these are the images and the metadata. So if you look at these images, these are the PIL formatted images, and then the metadata is these paths. Okay, and this is just an example, but we are going to do the same for all the images. right? When we create embeddings, we load all the images one by one and we create the embeddings. All right. So we need to create an index or database within the pinecone. It's a cloud-based one, right? So we are going to create that. So import the pinecone, and then we have the API key and the environment. I stored these two keys in my bash profile file so that you can get using this os.environment.get variable. Okay. So here we initialize the pinecone, or we are connecting to the pinecone. Okay. And then we are going to create an index or database. So we give the index a name. So here we are calling it satellite image search. And in addition to the name, two variables are mandatory. So the first one is the dimension of the vectors. So as I mentioned at the beginning, irrespective of the image size, when we create the embeddings, all embeddings are going to have the same vector size. Okay, so that's the dimension. Now we are going to use a clip model which will convert or which will transform each image into a vector of size 512. Okay, so that's the dimension of each vector. And then we'll define the metrics which we are going to use to measure the similarity between the vectors. Now the reason why we need to supply this is because when these vectors stored within the vector database, based on this similarity metric, the data is structured in a way so that this distance is already computed, and the vectors are stored so that finding similar vectors becomes easier and faster. Okay, so that's why we need to supply this metric when we create the database itself. All right, and then we are finally we have created the index and we have connected to the index. Now using this index, we can insert the data, we can delete the vectors, I mean we can query, etc. Right? We can do all operations which we do in a normal database, right? This is like a database connection. All right, and then we want to transform all the images into embeddings. So for that we are going to use this clip model. Now we have a within the clip models, it's a collection of models, right? Within it we have a model which is fine-tuned on satellite images so that the model can understand and find the features, the patterns better in satellite images. Okay, so we are going to use this a model which is trained on these satellite images. Okay, so this is our model, and then we have some pre-processing to do with the images. So this is our pre-processor, it's the clip processor, and then here we are accessing the model okay, from the transformers library. So when you run this command, it will take some time because it has to download the model to your local machine. All right, now in order to create the embeddings of the image, all we need to do is we supply the images. In the first step, we do the pre-processing of the images, and in the second step we create the embeddings or the vectors of the images. Okay, this function takes multiple images, pre-process those images, create vectors, and return the vectors as a list. Okay, all right, now let's create the embeddings, and while creating them we'll upload or upset to the database as well. Now we cannot upload all the images at the same time because of the memory issues, and also doing one at a time takes significant time because of the to and fro communication with the database. So what we do is we do in batches. So here we choose a batch size of 64. It's up to us. I mean, if the vector dimension is small, we can probably have a bigger number for batch size. But in our case, we have the vector size 1024. I think 512. So we are using a batch size of about 64. Okay. So in this for loop, we are simply going over all images, 64 images at a time, and then we are creating. So we are basically finding those 64 images, which is the path, and then we are loading the images. Okay, we are loading the images into the memory in the PIL format, and then we are creating the images. Okay, that's one thing. And then we need to create an ID for each vector. This can be a simple serial number, right? So that's what we are doing here. It's a simple serial number. And then the pinecone expect the data in this format. So the vectors, they should have the vector ID first and the vector itself, and finally this metadata. Now this metadata can be simply the path, or it can have some tags, or maybe the image itself, right? So whatever we want, we can store in this meta variable. Now this will be helpful when we want to do further filtering, or maybe we want to have the image information, so that as soon as we find the vector ID, we know the image information as well, right? So we prepare the data in these 3 elements format, and finally we just upload the data to the vector database, right? And there is a lot happening under the hood with this command. So as I mentioned, the distance metric which we have used as cosine. So when the vectors are upserted to the database, based on the distance, the similarity, etc., these vectors are structured in a way so that the retrieval and finding the similar vectors becomes easier. Now after inserting all the records, you can use the describe index, which will return these 2 sets of information. So this one, it's the vector dimension, which we already knew, and this one shows the number of vectors which are uploaded. Okay. Now and then, so the first part of the structure is done. So we up to this point, we have done all this. We started with some images. We have used clip model to transform these images into vectors of size 512. And then we have created a vector database with vector dimension 512 and the distance metric as cosine similarity. And then we have inserted or upserted all these vectors into the vector database. So this top portion is done. And now comes the application where we are going to query the images. Okay. So here we are searching the pinecone, and it's very simple. We supply a image, right? Now for that image, we create the embeddings. Okay. Once we create the embeddings, or this text vector, query vector, then we simply query the index using the newly created vector and these 2 optional arguments. Here we can specify how many similar images or vectors we want. So in this case, we are asking for 6, and it's optional to get or retrieve the metadata information. Okay. So once we get the results, we know the metadata as well as the IDs. So we use that information to load the images in PIL format. Okay. And then here the bit of HTML thing. So all we are doing is we are taking the images, and then we are just resizing them and showing the images in this Jupyter notebook. Okay. All right. It's the same code. Yeah. Okay. So let's start querying. Okay. So here we have taken one random image. It's the image ID 1524. It doesn't matter. You can take any image. So we load this image. Okay. We load this image, and here we are simply displaying the image. Okay, so we just resize it to 200 by 200 dimension, and this is our query image. What we are going to do, we are going to find out all the or the top 6 images which are similar to this image. Okay, so here we are calling the function search pinecone, which will take our query image as we have seen here. Search pinecone. So it will take our query image, it will create the embeddings, and then it will create query the pinecone index, and it will return the top 6 images which are similar to our query image. Okay. All right. So here are the 6 results. The first one will be the same as the image, because obviously the image is the closest to itself. are similar to itself. It's exact identical, right? So the first result is always going to be the image itself. Now, if we are using an image which is not in the database, then we'll get a different image as the first image also, right? So here these images are shown too close to each other, but I hope you can see, okay, this is the first image and this is the second image. This is the third image, fourth one, fifth one, and sixth one. Okay, so as you can see, these 6 images, they look very similar to our test image, which is this this agricultural land or this canopy or like that, right? And then let's do one thing. So here we are not using the image from our database, but we are loading an image from internet. Okay, so this is an image we are loading from the internet using the request library, right? So we are using this image as a test image. We are just showing this image. As you can see, these images, our database images are in this color, whereas this image, it's from the internet, it has different color palette, right? So for this image, we are using this as a query image and then searching pinecone for similar images. As you can see, it's these flyovers. So the first image is not the same as this because our database don't have this image. But as you can see, these are all these roads and these flyovers, bridges type of images, all these 6. Okay. And this is another image again coming from the internet. As you can see, this one also returns similar images. And then here we have a stadium. This image is also coming from the internet, not from the database. But as you can see, it's a sports stadium. So first, second, I guess this image, yeah, and the third, fourth, fifth, sixth. So all 6 images, they'll have the stadium and the ground within that images. Okay. And we have here, it's an airport runway. And as you can see, all these images, the returned images, these are all airport runway images. And finally, we have another test, another query image again coming from the internet, which is this shipyard with all these ships. As you can see, so these 6 images are also shipyard images. Okay, so our data set, it has different sets of images. We have built a system or an application where we can query these images so that we can find similar images. All right. And if you want, you can delete the database or the index simply using this delete index command. All right. That's it for this video. Thank you very much.